Our topic today is reasoning and proof. So our first space right here is the word inductive. Inductive reasoning is reasoning based on patterns you observe. So we're going to look at some examples. In these problems right here, we're going to look for a pattern. So notice I went from 1 to 4, from 4 to 16, from 16 to 64. What kind of ways can I get there? Think about that for a second. Did you come up with multiplying by 4? So that's one of the ways we wrote rules in Algebra 1. So looking here, I'd go 1 times 4 is 4, then 4 times 4 is 16, 16 times 4 is 64. So if I wanted to just determine the next couple of terms in the pattern, I would just take my calculator, and I would say, okay, well, 64 times 4 is 256. So then my next term would be 256. And then I would multiply that by 4. And my next term would be 1,024. Okay. Looking at this pattern over here, what are you noticing is happening as you go from one item to the next in the sequence? Well, this has 3 vertices, this has 4 vertices, this one has 5 vertices. So what do you think the next one's going to have? Well, it's going to have 6 vertices, and the one after that is going to have 7. So if you were to draw the next 2 pieces in this pattern, they would look like this. A hexagon and then a heptagon. So, draw those patterns. Now I want you to give these a try. Look at this one. What is the pattern you see? Give me the next 2 examples. And then give me this one as well. Okay, did you get the next 2, that these were circles that all ended up here at the top? So then the next 2 pieces of that pattern should look like this. And then the next one is numeric, and looking over here, I can see that I went from 16 to 8. How would I do that? I divided by 2, divided by 2, divided by 2, divided by 2. So the next term is going to be 1 divided by 2, which is half. And then the next term after that is going to be 1/2 divided by 2, which is 1/4. And that pattern would continue. Okay, once you're pretty sure that we understand a pattern, we can start to make conjectures. Conjectures are conclusions made using inductive reasoning. So this is conjectures. So let's try to figure out our next term in this pattern. Can you guess what the 20th picture would be? Well, let's start with the next one. So this is 1, then this is 2 by 2, this is 3 by 3, 4 by 4, so the next one is probably 5 by 5. Yeah, that makes sense. So the next one's going to be 5 by 5. The 20th one, well, we went from, the second term was 2 by 2, the third term was 3 by 3, the fourth term was 4 by 4, the fifth term was 5 by 5, so the 20th term is going to be 20 by 20. So it's going to be 20 dots this way and 20 dots that way. Okay, now you figure out this next one. Did you get that the 43rd term is I? So if you label each one of these 1, 2, 3, 4, 5, and then 1, 2, and we keep following the pattern, it's going to be 3, 4, 5. So this is just going to repeat. I have 5 terms that repeat over and over again. So the 10th term would be you. The 15th term would be you. The 20th term would be you. Keep going on and on until you find a multiple of 5. That's close to 43. That would be 40. So 40 would be you. 41, 42, 43 would be I. So that's how you get I there. Okay. A counterexample. Sadly, not all your conjectures will be true, and all you need to do is find one example of when it's not true to prove that your claim is false. So, your claim or your conjecture. A counterexample is an example that shows a conjecture is false. So we're going to give some counterexamples for the following statements. Here we go. If the name of a month starts with the letter J, it's a summer month. Well, summer month, June is summer, July is summer. Okay, but what about January? Well, January is in the middle of winter. It starts with the J, so this would be a counterexample. January makes this not a true statement. Multiplying a number by 2 makes it bigger. Well, that would make sense. 2 times 1 is 2, that's bigger. 2 times 4 is 8, that's bigger. But I'm only multiplying by positive numbers. What if I multiplied by a negative number? What if I said 2 times negative 1? Does that make it bigger? No, because it would become negative 2, and that's a smaller number. Okay, you try. Pause the video and give this one a try. Okay, your answer can be any student not in geometry. I'm sure you have plenty of students you know that aren't. Okay, conditional statements. Conditional statements are extremely useful in reasoning. Okay, conditional. And remember, vocabulary intent unit, it's going to be very intense with vocabulary. Conditional statements, extremely useful in reasoning. A conditional statement is a statement that can be written as an if-then statement. So here's some examples. If you complete the entire packet on your own, then you will master the check. Then you will pass the mastery check. Right? That's an if-then conditional statement. If you do this, then this will happen. Number 2 says, if you drink coffee late at night, there's an implied then here, even though it's not said, then you will have trouble sleeping. So this is my if, then. Okay? So when Sully stays up late, it's to catch Santa Claus. So this is kind of an if-then. If Sally stays up late, then she's going to catch Santa. Obviously, we're talking about, Christmas Eve. Number 4, dolphins are mammals. This is not a conditional statement. This one is not clearly a conditional statement. Let's rewrite number 3. Number 3 should say, if Sully stays up late. It is to catch Santa, so then she will catch Santa. And number 4 says, dolphins are mammals. That is a statement. It's not conditional. But you could say, if you are a dolphin, then you are a mammal. That is a conditional statement. So if, then. So you give it a try with the next 2. Okay, did you get if the figure is a quadrilateral, then it has 4 sides? And did you get if the lines are parallel, then they'll never intersect? Those are 2 good ways to rewrite these 2 conditional statements. Okay. Each conditional can be broken down into the if part called the hypothesis and the then part called the conclusion. So, identifying the hypothesis and conclusion of each of the conditional statements below, here we go. If Sully shoots the ball, the hypothesis is Sully shoots the ball. Right? The conclusion is then the shot will be an air ball. Sounds like Sully doesn't shoot very well, does it? So this is my conclusion. So, if a triangle is an equilateral, this is the hypothesis, then it is isosceles. This is the conclusion. So, give it a try with these questions right here. Oh, write your questions right here. If you have any questions about this, make a note so that you know to ask me. Okay. Now, related conditional statements. If you have a conditional statement, there are several related statements you can make. So, one of the things you need to be careful of or be aware of is notation. So the negation, which is the opposite of a statement, usually said not P or written as not P. You see that little tilde there? That means not P. So every time you see that, it means the counter or the not before that statement. So if I study really hard, then I earned an A on the test. That's just a straight if-then. If I studied really hard, then I earned an A. The converse would be taking the conditional statement and switching the hypothesis and the conclusion, which says, if I earned an A, which remember, let's go back up here. This is my hypothesis. This is my conclusion. So the converse would be switching them. If I earned an A on the test, then I studied really hard. Okay? So this is direction. So studied gives me an A. The converse says that A means that I studied. The inverse is taking the conditional and negating both the hypothesis and the conclusion. So up here the original statement says if I did study, or if I studied, but the inverse would be if I didn't study really hard, then I, and the inverse of this, would not earn an A on the test. Right? Or I didn't earn an A on the test. So these little symbols right here means not studying gave me a not A, basically. Counterpositive. Take a conditional statement and switch and negate both the hypothesis and the conclusion. So now I'm taking it, I'm doing the converse, and I'm making it an inverse. So I'm conversing, inversing. So it's called a contrapositive. So taking the hypothesis, the conclusion, and making it the hypothesis, but using the not form of it. If I don't earn an A on the test, then now I'm taking the hypothesis and I'm making it the conclusion, but I'm taking the opposite of it. Then I didn't study really hard, right? So if not A, then not S. So if I didn't get an A, then I didn't study hard. Okay, some of the things that you need to be aware of. A term, the truth value of a sentence is true or false. So when I make a conditional statement, or I make a statement, the statement is either true or false. A sentence in the form of if A then B is true unless A is true and B is false. So if I make a statement where A is true and B is false, then it's a false truth value. Okay? In this case, let's just say that the case A is that 2 is even. That's true. And let's say that New York has a large population. That's true. That's B. So if I put those two things together, I could evaluate that as a compound statement. It would say A is even and New York has a large population. That has truth. Both of those are true statements. Okay? Well, the contrapositive will always have the same truth value as the original condition. So the converse and inverse might have the same truth value, but it also might not have the same truth value. So here's what I'm talking about. When I have a conditional statement, if P then Q, right here, then its converse, and this statement is true, then its contrapositive is going to be true. If this statement is false, then its contrapositive statement will be false. These kind of go between. So, if we go back to my statement, if you are a dolphin, you are a mammal. So if I took the opposite of that, or if I made that a not true statement, if you are a dolphin, that's true, right? Let's say you are a dolphin, then you're a fish. Well, that's false because dolphins are not fish, right? If I did the counterpositive of that, then I would say if I'm not a fish, then I'm not a dolphin. That's not true either. So see how those both became negative truth values? Okay. This is where it starts getting hard because you have to start looking at all the different ways you say things. If you notice, the inverse is the contrapositive of the converse, therefore the inverse and the converse will always have the same truth value. So these two will also always agree. So these two will agree, these two will agree in truth value. So there's your introductions to reasoning and proof. You're going to have some stuff to work on in class. If you have any questions, make sure you make a note. I will see you tomorrow.